All right, so for today's class, we are still focused on standard AEE4. Our learning intention states, we are learning to write equations of lines in different forms in order to understand linear relationship between quantities. When we talk about different forms, you will see what I'm talking about. Our success criteria states, I will be successful when I can translate the equation of a line from standard form to slope intercept form and point slope and vice versa. There's a whole bunch of slopes in this, okay? It's the same stuff. We've been doing slope intercept form. So when we talk about y equals mx plus b, that is in the slope intercept form. Now we're gonna look at how we could rewrite it in different forms. On our agenda, you'll state, we review the different forms, and then I've already posted the assignments. Let me know if you have any questions about that. The first one we're going to look at is the point slope form, okay? I'm going to do this by doing some examples. So for example, so if I say the slope, which is m, is equal to 2, right? Actually, no, let's reverse a little bit. When we talk about the point slope form, talk about y minus y1 is equal to m times x minus x1. And ideally, the numbers that you want to substitute into this form is the x1, the m, and the y1. It's called the point slope form because it involves the point and the slope. All right, so for example, if I say the slope of a line is 2 and it goes through the point 3, 4. All right, I will label these as x1 and y1. Okay, so then now if I'm writing my point slope form, it would be y minus the y value is 4. 4 is equal to the slope is 2, open parentheses, x minus 3. So whenever we say put an equation in point slope form, this is basically what we're looking for at this point. All right. Let me go back. Sorry. That's in point slope form. Let me erase this right here and then I'm gonna move this over. That's in point slope form. Now from here, we could move over to standard form. So let me put a line. And now we're gonna talk about if something is in standard form. All right. When something is in standard form, it looks like this. AX plus BY equals C, where A, B, and C are constants. Right? A, B, and C are constants. I think it's a different color. And where X and Y are variables. All right, so it's in this form. So whenever we have an equation in this form, then we know it's in standard form. So I'm going to take the example that I used before on this other side right here. Where is it at? Y minus 4 is equal to 2. And then I'm going to put this equation in standard form. I work it out like I normally do with regular equations, actually. Y minus 4 is equal to 2x minus 6. Right? And then with my standard form, I know that I need my x and y variable on the left side. Since I need my x and y variable on the left, right? My left hand y variable on the left side, so I need to move that on that side. All right, so I'm gonna move this over here so it becomes y minus 2x is equal to negative 6 plus 4. So I move the 4 on the other side, and then I move the 2x on that side. Now I have my x and y on that side, and then my number on the other side, my constant that doesn't have a variable, which in this case would be c. So if I solve this out, I get negative 2 right there. And I'm going to rearrange it so that my x variable is first and my y variable is second. So this becomes negative 2x plus y equals negative 2. Do you realize that it's in the form of the same one? Do we see that? That this right here is in the same form of this right at the bottom? Yeah, so now we know it's in standard form. So I took it from point slope form to standard form. All right, from point slope form to standard form. If I wanted all this to be positive, the opposite, if I times everything by -1, just so that it looks prettier. If I times everything by -1, this becomes positive 2x, this becomes minus y, and this becomes 2. Do we see that? If I times everything right here by -1, this is what I'll end up getting. I can do that. It's just that I have to times all of them by the same term. So I did times it by -1. So then that turns out now. So now I have my standard form. Okay. Just to recap what I said, I did the minus to show you that you could do that as long as you do it to each term. You could do that with anything actually. So if there's a number that you want it to be positive, but it's negative, just times it by a -1, but just know that you have to do that for each term as well. Now, the last one we're gonna look at is the slope intercept form, which is the one that we've been doing, y equals mx plus b, okay? So I'm gonna go over here. Now we're gonna talk about the slope intercept. And this is the one where it's y equals mx plus b. We need it in this form, okay? This is what we've been doing, right? So I'm gonna go back to the question that was over here. So this one right here where it says 2x minus y equals 2. I'm gonna take that 2x minus y equals 2. Do we see how that we could get that to this form? How we could rearrange it so that we get to here? Yeah. So from here, I realized that I need to have y by itself on one side. And it's already kind of lined out. So if I just do a plus y, but then do the same thing on this side, but then if I do that, I have to get the 2 away. I have to minus 2 as well. So I'm going to -2 on this side. So then I'm left with 2x minus 2 is equal to y. And I'm going to rewrite this so that it looks a little bit different. Y is equal to 2x minus 2. We just got to ensure with this that the y is positive. We don't want to leave a negative y. So for example, if I had moved over the, if I had moved over to 2x instead, right? I would have had negative y is equal to negative 2x plus 2. So it's laid out, however, this y is negative. So in order to make it positive, I need to multiply it by a negative 1, because that makes it a positive y. But if I do that, I have to do it to everything. So I have to multiply negative 2x by negative 1, which makes it a 2x, and then a positive 2 times negative 1, which makes it a negative 2. So then you'll end up with the same answer. However, point slope form. This is the point slope form. So when we're talking about putting an equation in point slope form, this is what we're talking about. This video is going to be so important for you to review and learn and all them stuff. Okay. Basically, the three forms, and they're all interconnected. All right. There's none that's not interconnected. If you have any questions about this, let me know.